So what I've just demonstrated is the Moog Grandmother working in a duophonic mode. So the whole duophonic mechanism patch is using the voltage processor on the ARP 2600. To understand how the duophonic mode is working, you have to understand how the control voltages are routed and mixed on the Moog Grandmother. The CV is available internally and is patched from CV out to the CV ins on the oscillators. The separate CV ins here are summed with the one from the thing, so these are additive. They're not. They don't replace. So if you put a control voltage in here, here, it adds it to the one from the keyboard. Same thing here. So for instance, if you want one oscillator to drone at a constant frequency and the other one to react with the keyboard, what you have to actually do typically is to take the control voltage out from here, go through the attenuverter, set to negative values, and feed that back in. So basically you subtract the keyboard value from itself, which gives you 0. And so then you have an oscillator that can drone. So what this patch is doing is using the voltage processor on the ARP 2600 to do the same thing, but also add in a second voltage, which is the second note. So basically the wire that goes to the grandmother and plugged into one of the oscillators. What's happening here is that the keyboard value from the grandmother is being sent over to the voltage processor. So this output here is the negative of this, because it has the voltage processor has an inverter, and it's adding in a second signal. That second signal comes from another inverter, which is taking the second keyboard output and adding it to the signal going to the grandmother. So the MIDI implementation on the 2600 has two keyboard voltages, the upper and lower notes basically. And so we're taking the lower note, which is being controlled through MIDI from the grandmother, and basically routing that to the second oscillator, and we subtract the Moog's keyboard voltage, so that the second oscillator basically plays just the note that's coming out of the second CV on the 2600. So this basically allows you to take the grandmother and run it in a duophonic mode. I've been looking at actually building my own hardware with a couple of ARP amps and to do the same sort of thing, but I realized that the voltage processor on the 2600 can be used to do exactly the same thing. So if you just play one note at a time, you get obviously the standard thing, because the both oscillators are using the same voltage. And that's the way the MIDI implementation is done on the 2600. The CV2 is only one note playing, the same as CV1. But if I play a second note, I now get two different frequencies coming out. So I hope this is a useful patch. If you have a voltage processor that can be used to provide the negative value and add another value together. So for instance, we could actually use the attenuverter to provide one of the signals, and as a simple summer, unity gain summer, to add the two signals, the extra signal together. And if the extra signal is conveniently available on the 2600 as the CV2, because it already supports duophonic mode. Otherwise, a different CV source would be required, and that could come from anywhere, in the sense that you could have a second keyboard to provide the second value. So, as an example, I can use the keyboard associated with the 2600 to provide a second value. Although it's not providing the gate, so there we go. Duophonic Moog Grandmother by using an external voltage processor.